We're constantly hearing about the next big thing in crypto, right? But let's face the facts. The energy consumption, it's a huge hurdle for traditional ones like Bitcoin. I mean, think about this. A single Bitcoin transaction, it uses around 1,200 kilowatt hours.
Yeah, that's massive.
Enough to power like an average U.S. home for over a month. Or, get this, handle 100,000 Visa transactions.
Wow. And globally.
Globally, Bitcoin's pulling more than 160 terawatt hours a year.
Which is more than entire countries I've read, like Argentina.
Argentina, Finland, yeah. And the carbon footprint, over 60 million tons of CO2 every year.
And a big chunk of that is non-renewable energy, right? A huge chunk, like 67%. So
yeah,
it's a problem. Okay, so let's unpack what could be maybe a turning point here.
Well, what's interesting is seeing solutions pop up that are aimed squarely at that exact challenge. Today, we're diving into Bitcoin London Coin, BLC for short.
BLC. The folks behind it are calling it a future-proof evolution of Bitcoin, designed specifically to, tackle those environmental issues, but also, and this is key, to leverage AI and boost security at the same time.
So the core promise is a greener blockchain.
Greener, smarter, and safer. That's their tagline, essentially.
Okay, greener, smarter, safer. And to really get into this, we've got their own documents.
Right. What are you looking at?
We've got excerpts from the BLC white paper, their investment memorandum, the financial strategy for the company, London Coin Systems, LTD, and even their PR plan.
So a good cross-section of materials.
Exactly. So our mission today really is to understand how BLC is trying to shake things up, how it's focusing on sustainability, weaving in AI, strengthening security, and also finding real-world uses, especially this new partnership they have in South Korea.
Okay, makes sense. So where should we start? That energy problem seems like the logical place.
Definitely. The elephant in the room, traditional mining.
Right. Bitcoin, the older cryptocurrencies, they use something called proof of work. POW.
Okay, POW. Now, maybe for someone who's heard the term but isn't totally clear, can you break down what proof of work actually is and why it uses so much darn energy?
Sure. So proof of work, it's basically a system. Computers, often very specialized ones, are all competing.
Competing to do what?
To solve these incredibly complex cryptographic puzzles. But here's the thing. The puzzles themselves are, well, ultimately kind of pointless beyond securing the network.
Pointless?
Yeah, they don't produce any other useful output. The first computer to crack the puzzle gets to validate a block of transactions, add it to the chain, and they get a reward, usually in the crypto itself.
Okay.
But the catch is, this competition needs just immense amounts of computing power running flat out all the time. And that's where the huge energy consumption comes from.
Like a global lottery using supercomputers burning energy just to find the winning ticket.
That's a pretty good analogy, actually. A very, very energy-intensive lottery.
Okay, pointless puzzles. That's really sticking with me. All that electricity, all that hardware, just for an arbitrary math problem.
Essentially, yes. It secures the network, which is its function, but the work itself isn't useful beyond that.
So how does BLC plan to change that? What's their alternative?
Right. This is the core of their innovation. BLC uses something different. Proof of useful work. PAUW.
Proof of useful work. Okay, that name says a lot.
It does. Instead of those meaningless puzzles, PUW redirects that computational power. It uses it to process real-world, valuable AI tasks.
Whoa, okay. Now that is interesting. So the mining isn't just burning energy anymore, it's actually doing something productive.
Exactly.
What kind of useful work are we talking about? What kind of AI tasks?
Well, their documents mention things like training machine learning models, natural language processing, running large-scale simulations.
So those energy-hungry mining rigs could become part of, like, a giant distributed supercomputer?
That's the idea. Contributing computing power to actual AI advancement. So it's not just about making Bitcoin greener.
It's about fundamentally changing what blockchain mining is.
Exactly. Rethinking the purpose. Imagine if all that hashing power, billions spent globally, was actually solving scientific problems or, complex business analytics.
Yeah.
That's the potential they're aiming for.
That's a big shift. A real win-win, maybe. Less environmental damage because the energy use has a purpose.
Right.
And you're also speeding up AI progress.
That's the dual benefit they highlight.
But the sustainability angle. Didn't you mention something else? Something about CD-ROMs. Sounds a bit retro.
It does, doesn't it? But it's quite innovative, actually. They plan to integrate petabyte-scale CD-ROM drives.
Petabyte scale on CD-ROMs?
Yeah, massive capacity. The idea is for data storage and retrieval. They physically etch the blockchain data onto these disks.
Why? What's the advantage?
Well, two things mainly. First, sustainability. They argue it's a much lower energy footprint for long-term storage compared to, say, constantly powered hard drives or SSDs in a data center.
Okay, lower energy. And second,
Security and immutability. Because the data is physically recorded, like burned onto the disk, and these disks are distributed. It's incredibly hard to alter after the fact. It's hardware-based immutability.
so you can't just digitally hack it and change past records. It's physically there.
Precisely. It adds this very physical layer of permanence and security, a different kind of security than purely digital systems.
Lower energy storage plus a physical, almost unchangeable record. That's interesting on the green and safe fronts. Okay, let's pivot to the smarter side then. This decentralized AI marketplace. How does that actually work?
Well, it connects directly to the proof of useful work concept, right?
Okay.
So BLC envisions this platform. Users, maybe researchers, maybe businesses can submit AI tasks they need done.
Like, I need this machine learning model trained or analyze this huge data set.
Exactly, things like that. And then the miners on the BLC network who are already set up for computation because of PayUW,
They pick up these tasks.
they pick up and execute these tasks using their computing power.
So the miner's incentive changes. It's not just validating blocks anymore. They get rewarded in BLC for doing this AI work.
That's the model. It essentially creates this whole new economy running on the blockchain, powered by useful computation.
And how does BLC, the platform, make money from this?
Well, the documents suggest fees for submitting tasks. Maybe tiered fees, like you pay more if you need your task done faster. Prioritized.
Right, a marketplace model.
It's a direct way to monetize all that useful work happening on the network.
Can you give us a sort of concrete example? Like, what kind of task could a small business actually use this for? And would it be cheaper than, say, Amazon Web Services or Google Cloud AI?
They don't detail specific pricing comparisons in the docs we have, but the implication is it would be competitive because it's leveraging this distributed network. So a small e-commerce business might submit image recognition tasks, for tagging products, or maybe analyzing customer reviews for sentiment.
Okay. Or a university researcher running simulations.
Exactly. Complex scientific modeling, perhaps. Things that need a lot of processing power.
Okay, got it. So we've hit greener, smarter, now for safer. You mentioned quantum computing threats earlier. Sounds pretty serious.
It does sound a bit sci-fi, but yeah, it's a real long-term concern for, well, pretty much all current digital security, including blockchains.
How so? What's the threat?
Basically, quantum computers, once they become powerful enough and their documents mention a codename Willow for this potential threat, could theoretically break the standard encryption algorithms used today.
Break the encryption that secures Bitcoin, Ethereum, everything.
Potentially, yes. The cryptography relies on math problems that are incredibly hard for current computers, but might be solvable for large quantum computers.
Okay, that's unsettling. So how is BLC preparing for this potential quantum apocalypse?
Well, they're proposing a few layers of defense. First, at the software level, they're implementing quantum-resistant algorithms.
What does that mean exactly?
It means using newer types of encryption that are based on mathematical problems believed to be hard even for quantum computers. They mention state-of-the-art encryption.
Okay, so upgrading the locks, essentially, to something quantum computers can't pick easily.
That's a good way to put it. They also mention software-based load balancing for fast block generation as part of this security picture.
And is that hardware thing, the CD-ROMs, play into the security against quantum, too?
Absolutely. That hardware-based immutability adds another layer. Even if someone could somehow break the crypto in the future, the historical record physically exists on those distributed disks. It's a physical backstop.
A physical safeguard for the blockchain's history. Okay. Now, what about speed and scalability? Those are always big sticking points for blockchains. How does BLC plan to handle lots of transactions quickly?
Their main answer seems to be that load balancing architecture we mentioned, by spreading the work efficiently across the network.
Like traffic management.
Exactly. Like a smart traffic system for transactions.
Yeah.
They aim for ultra-fast processing, even when the network is really busy.
And those massive CD-ROMs, they must help with handling all the data too, right, as the chain grows.
That's the plan.
Yeah.
Those petabyte drives are meant for decentralized data storage and retrieval at scale, supporting a growing ecosystem without data access becoming a bottleneck.
Okay. This is all very ambitious technologically. Let's switch to something more grounded, this partnership in South Korea. KFME.
Yes, the Korea Federation of Micro Enterprises.
Mhm.
This looks like their flagship real-world application right now.
And KFME is big.
Huge.
Yeah.
According to the BLC documents, KFME represents 7 million stores. 7 million.
Wow.
That's apparently 82% of all micro enterprises in South Korea. So, yeah, it's a massive organization.
And the partnership means what up? These stores will accept BLC for payments?
That's the goal. They signed an MOU, a Memorandum of Understanding, back in May 2025 to enable exactly that, allowing these millions of small shops to take BLC.
That potentially taps into a huge market. South Korea's digital payments market. What did the doc say? $250 billion.
Around $250 billion, yeah. And they mentioned there are already about 17 million crypto users in South Korea. So there's an existing base.
What kind of financial impact are they actually projecting from this KFME deal?
The numbers are pretty big. They're hoping for about $530 million just in initial token sales.
How do they get that figure?
They project 5.3 million KFME members buying $100 worth of BLC each. That's their assumption.
Okay, that's one stream. What else?
Transaction fees. They estimate collecting around $269 million a year.
Based on what?
Based on a 2% fee on an estimated $13.46 billion in annual transaction volume through those KFME stores.
And there was a third thing, setup fees.
Yeah, setup fees for the stores to actually integrate the BLC payment system. They project maybe $350 million from that, charging $50 per store.
Those are certainly some eye-popping numbers. But, crypto adoption can be volatile. Competition is fierce. Does their investment memo acknowledge risks that could stop them hitting those targets?
Oh yeah, standard risk disclosures are there, market adoption risk, competition risk. But they seem to be banking heavily on the first mover advantage here and the network effects of partnering with such a massive organization like KFME right off the bat.
Okay. And how are they planning to launch this in Korea? Get the word out.
Their PR plan seems heavily focused on it. They specifically mention a press conference in Seoul, planned for May 9th, 2025.
Aiming for a big splash.
The very big splash. Goal is 15 million plus media impressions. They talk about using local media, popular Korean social platforms like Kakao Talk and Naver.
Influencers?
Even K-pop influencers, yeah. Trying to build awareness quickly among both consumers and those small businesses.
Okay, let's zoom out a bit. The
Yeah.
overall financial picture for BLC, what kind of valuation are they actually aiming for?
They're targeting somewhere in the $2 to $5 billion range for valuation,
Driven by.
driven by those potential token sales,
Yeah.
the KFME transaction fees we just talked about, and then the future growth they expect from that AI marketplace.
And you mentioned their revenue streams are pretty diverse, not just the token itself.
Right. It's the transaction fees from payments, fees from the AI marketplace, the minor rewards, which circulate value, potentially fees for other ecosystem services, like integrating with other merchants or platforms,
And maybe premium features later on.
and premium features down the line, yes.
Yeah.
A multi-pronged approach.
Okay. Total supply is capped, like Bitcoin, at 21 million BLC.
Yes. 21 million total BLC tokens.
How are those getting distributed? The tokenomics?
It's broken down quite specifically in their documents. So 10% goes to existing Bitcoin holders at the time they fork or launch.
Okay, an airdrop kind of thing.
Seems like it. Then 10% for tech development, 10% for the miners doing the proof of useful work, 10% for developers building on BLC,
Incentives.
0.10% for the initial coin offering and public sale, 10% for marketing,
Right.
then 20% for the management team, and a final 20% is held in reserve by the company, London Coin Systems.
20% for management, 20% reserve. Okay.
Yeah, fairly significant chunks there.
Now, launching something like this, it never happens in a vacuum, right? What kind of big economic factors are they worried about? External stuff.
Their financial strategy docs definitely address that. They explicitly mention watching U.S. tariffs, for instance.
Yeah.
They estimate a potential impact of maybe 23% on certain things.
Tariffs. Okay. What else?
Inflation, naturally. They're projecting rates between about 2.7% and 3.8% in their planning horizon. And of course, just the general volatility of the crypto market itself.
Standard crypto craziness.
Pretty much, yeah. It's a known factor.
So how do they plan to navigate all that? Tariffs, inflation, volatility.
They outline several strategies. One big one is that revenue diversification. We talked about AI marketplace, fees, not just token price.
Don't put all eggs in one basket.
Exactly. Then cost optimization is huge. They're looking at localized operations in places like Canada or Singapore, potentially to avoid tariff issues. They emphasize energy efficiency, obviously, with PowerUW and renewables, diversifying supply chains, maybe within Asian countries, even automation to cut costs.
Seems thorough. What about managing the financial risks directly, like the volatility?
Yeah, risk management is another pillar. They talk about holding gold-backed reserves, possibly as an inflation hedge, diversifying their own asset portfolio, using hedging instruments against market swings, and getting cyber insurance for security breaches.
Gold reserves, hedging, insurance, trying to cover the bases?
Seems like it. They're trying to build in resilience.
I also saw something about an America First marketing angle. How does that fit in?
Yeah, that was interesting. Seems like a strategic play, maybe to counter the tariff concerns or just appeal to the U.S. market. The idea is to highlight BLC's green tech side and its potential to create jobs, specifically in the U.S.
Playing up the domestic benefits. Makes sense politically, maybe.
Could be.
All right, we have covered a lot of ground here in this deep dive. If we boil it down, what are the main takeaways on BLC?
Okay, I think the big things are, first, that fundamental shift away from traditional proof of work with their proof of useful work. That's core.
Tackling sustainability by making the work useful. AI computations.
Exactly. Second, addressing future security threats like quantum computing with resistant algorithms and that unique CD-ROM hardware layer for immutability.
Okay.
And third, probably the most immediate tangible thing is that big strategic partnership in South Korea with KFME. That represents a massive real-world test case and market opportunity.
Yes, 7 million potential stores is nothing to sneeze at.
Definitely not. It shows serious intent for adoption.
So it really sounds like they're trying to make waves in both crypto and AI.
That seems to be the ambition, yes. Merging the two fields in a way.
And it leaves you thinking, doesn't it, with the environmental cost of so much tech. Could these kinds of models, like proof of useful work, could they be more than just an evolution, maybe a necessary shift?
It's a provocative thought, for sure. A paradigm shift, not just for blockchain, but maybe for other big computing tasks, too.
What other huge real-world problems could we maybe tackle if we could incentivize useful computation like this through decentralized networks?
Right. Beyond just AI as the scientific research, climate modeling, who knows? It definitely opens up some interesting possibilities to think about.